Good afternoon, everybody. Welcome to an afternoon of Chem 1105 with your host, me, Dr. White. And I'd like to apologize. Sorry, I'm running late. Today's been a very busy day for me, if that's an understatement. All right. By now, hopefully, you've all realized that today, earlier this morning, I sent out the password for the password protected PDF file for test number 1. And if you go to the assignment area Blackboard, you'll see test number 1. You can download that. Here's the periodic table you should be using. And instructions if you haven't figured out how to upload your test number 1. And the same thing is similar for lab reports as a PDF file. And if you need, there's Can Scanner, which is a pretty good app. I don't use it because I've got my own scanner, but over the last couple of years, a lot of my students have been using it, and it's pretty straightforward. Don't forget, you have until tomorrow, and notice it's due by 4 p.m. It's 10 points, and don't forget to upload it with your answers. One of your colleagues just asked a very good question. Once you download it, well, let me shut this off, go back to full screen. Once you download the test, there's no clock that starts running. Once you download it, you have until tomorrow to open it up and take the test. And you have until tomorrow, the only deadline is get it uploaded by 4 p.m. So does that answer your question? And once you start, you can take as much time as you need. Don't tell anybody I said that, but you can't. But make sure you have the answers uploaded by 4 p.m. tomorrow. And don't forget, and I have that in the email I sent you, before you upload your answer, highlight those special effects, upload your answer to Blackboard, make sure you check your PDF file and you have every question you answered in that PDF file. I've had students that are missing a page and I have to go back and track them down, and that's not good. So make sure you check. All right, let's take a look at today's lab. And if you go to the assignment area of Blackboard, you'll see lab number 6, balancing chemical equations. And I have either a PDF or a Word document you can download. And what do I have there? Today's lab. Now, this is the only one of the few labs you don't have to do a selfie. If you want, go right ahead, but you don't have to. And what you'll be doing for today's lab is problem set 1. And then the second page, this also, you will be balancing the chemical equations. Now, let me point out one thing is sort of hidden. If you look after J, there's a question which students forget. What is the sum of the coefficients in the balanced form of the equation in problem 1J? Or is that I? Hold on, let me take a look. And the answer is 1I. And that's this one right here. You have to add the coefficients. Now, yesterday I went through this, but let's go through it again. When you're balanced, when you have a chemical equation, if this is a chemical equation, the compounds at the base of the arrow are the reactants. The chemicals or compounds at the head of the arrow are the product or products. So A and B are the reactants, C and D are the products. Now, during the semester, since I've spent many decades in the chemical industry, you'll sometimes hear me saying that A and B are the starting materials. And if you work in the chemical industry, we don't call them reactants, we call them starting materials. All right, now, remember that for a chemical equation, there has to be conservation of matter. That means at the base of the arrow and at the head, the reactants and products, you should have the same number and same type of atoms. Because in a chemical reaction, you do not create or destroy atoms. And therefore, notice here I have 2 oxygen. Here I only have 1. Well, how do I get this to 2? You can't change the formula, but you can change the number in front. And that number is the coefficient. And when there's no number, it's assumed that's number 1. Well, to get 2 oxygens, I'll put the number 2. 2 times 1, 2 oxygen. But now on the product side, we have 4 hydrogens. 2 times 2 is 4. How do we get 4 on this side? Again, change the coefficient, and 2 times 2 is 4. We have 4 hydrogen, 2 oxygen, 2 oxygen. Now, yesterday, and it's still good today, I gave some important advice how to balance chemical equations. And my advice to you is, it makes your life a lot easier balancing chemical equations. Leave hydrogen and oxygen last. Now, if you notice, this is called heptane. And it has 7 carbons, 16 hydrogens. And if we look on this side, we only have 1 carbon. So it's not balanced. And guess what? I'm going to be real nice and let you try first. Why don't you try balancing that chemical equation? Remember, we did stuff like this yesterday. Leave hydrogen, oxygen last. Your turn. And let me relaunch the poll. When you're done, say yes. Don't use the second choice. This when you're done. All right, everybody's done. All right, let's do it. Well, I'm going to follow my own advice. That's good. And there's 7 carbons here. Remember the side draw, write a 7. To get to 7, I'll change the coefficient in front. 7 times 1, 7 carbon. Now, guess what? I only have hydrogen and oxygen left. So I'm going to do hydrogen left next. There's 6, and it doesn't matter which one you do, but I'll do this one. There's 16 here. Oh no, there's only 2 here. How do I get that to 16? I put an 8 there. 2 times 8 is 16 hydrogens. And finally, oxygen. Here we have 2. Remember, when you're looking at an atom, you add up all the atoms on the side you're looking at in all the molecules. And on the product side, we have 7 times 2 is 14 oxygen. We have 8 times 1, which is 8 oxygen, and add that all together. And hopefully I did it right, 22 oxygen. And how do we get 22 oxygen on this side? Well, 2 goes into 22 11 times. And let me move the plus sign over. And therefore 11 times 2 is 22 oxygen. So let's check, is it balanced? 7 carbon, 7 carbon. 16 hydrogen, 16 hydrogen, 22 oxygen. Yay, 22 oxygen. And it's balanced. Now, someone beat me to the punch. That's an American expression. What's the sum of the coefficients? What's the coefficient in front of C7H16? 1. Then we have plus 11, plus 7, plus 8. So it'd be 16 plus 11, the total, 1 plus, or I can do it this way, 12 plus 15 equals 27. If I did my math correctly, let's find out. 1 plus 11 is 12, 7 plus 8 is 15, and that's 27. Oh, I got it right. Remember, when there's no coefficient, it's the number 1. So it's important. Even though right here you don't see a number, it's the number 1 when you don't see one. And that's how you do the coefficients. Now, let me just show you one more that I did yesterday. You take iron and react it with oxygen gas. O2, you'll get ferric oxide, also known as iron oxide, also known as rust. And this is how to rust on a car when the paint, which is a coating protecting the metal underneath from oxygen, gets chipped away, you'll see rust form. And this is a case we call even, odd. And what we mean by that is here I have even number of oxygen atoms, 2. Here I have an odd. There's no way I can multiply the number 2 by a whole number. Remember, coefficients are always whole numbers to get the number 3. There's no way I can multiply the number 3 by a whole number to get the number 2. But what's the number they both go into to give whole numbers? And that's the answer. Simplest one, 2 times 3 is 6. So if I want 6 oxygen on both sides, how do I get it on this side? 2 into 6, 3 times. If I want 6 oxygens on this side, 3 goes into 6, 2 times. So now I have my 6 oxygen, but 2 times 2, 4 iron. How do I get 4 on this side? Put a coefficient 4, number 4 in front of there, 4 iron. And here we have 4 iron, 4 iron, 6, 6. And it's done. Now, one other thing I want to remind you, let's go back and look at this reaction that we balance. I could have said this, and notice I'd have 12 hydrogens, 6 oxygen, 12 hydrogens, 6 oxygen. And you say, well, that's balanced. And the answer is wrong. It's, that's a good question, Yulia. I'll come back to that in a second. Now, if you can divide all the coefficients by the same number and get a whole number, then you should. If I divide them all by 3, I'll come back to here. Notice this equation, I can't divide all the coefficients by the same number and get a whole number. Well, if I divide 2 by 2, that's 1, but the coefficient here is the number 1, and if I divide that by 2, that's 1/2. You can't have a coefficient that has fractions or decimals. Coefficients are whole numbers. So whenever you can, like in this case, divide all the coefficients by a number to get a whole number, you keep on doing that until you come to the point where you can't. I could have had 12, 6, 12. If I divide that by 3, I'd come here and do another 3, come here. So that's an important thing. Now let's go back to the actual problem set, or not problem set. Well, it says problem set. The lab you'll be handing in next week. Because remember, Tuesday is the 4th of July, and we'll have no class and no lab because it's a national holiday. Oh, by the way, you want to come on Monday or watch the video, you'll see a special something for the 4th of July from Dr. White. Shh, I'm not going to give it away. You got to come or watch the video. All right, let's look at these. Now, this is a problem set I didn't create, but I use. And a couple of things. In here, which I don't do on a test, they have in the bracket to the right of the chemical formula, S means solid, G means gas. They have an L here. I can't see one off the top of my head. L means liquid. Ignore, oh, I do. Here, L is liquid. Ignore, and water too, liquid. Ignore those letters. But it means solid gas, or solid, liquid to solid plus a gas. Just ignore that. Now, one other thing that I will not do on my test, but this problem set or this exercise has, some of these are already balanced. And that would be a correct answer for this lab. On my test, and I said yesterday, I'll have at least 3, maybe 4 balanced chemical equations. There'll be 3 points each. If I ask you to balance in a chemical equation, you will have to balance it. But for the lab, which I didn't create, there'll be some, maybe 1 or 2 or 3, I don't remember how many, where it's already balanced. And this is due, I think a week from today. and that gives you plenty of time to do it. And I've had this lab because it's good practice. Besides my problem set, this lab will be good practice. So, are there any questions? All right. Well, that's the lab. Don't forget the lab you did Tuesday, which is supposed to be due today. I have it done, I think, due next Wednesday, because it's a lot of work when you do Tuesday's lab. Make sure, if you haven't done it, wear safety goggles for this one, since you're not dealing with any chemicals. You're just writing on a piece of paper. You don't have to put on your safety goggles. But for chemicals, when you handle it, put on your safety goggles, wear gloves. And as I mentioned Tuesday, for the lab on Tuesday, I would do it in a foil pan, which I showed you. The cheapest place I found to buy those are Walmart. I got to find a way to get a kickback from Walmart for telling people to go there, or Target, or as my friend calls it, Target, or anywhere else, Jewel too. Let's see how much they cost in Jewel. If you notice, Walmart is still the cheapest place to buy these, looks like. So unless you don't want to go to Walmart. Yeah, I think they were $1.24 at Walmart. Here, the same thing, it looks like about $2.54. So it's not that much different. But if you want to save $1, go to Walmart. If not, you can get them at Jewel. Ah, thank you. I haven't been in Dollar Tree in ages. How much was it in a Dollar Tree? Was it actually $1 for one or two? The stuff in Dollar Tree, some of it's more than $1. All right. So thanks to one of your colleagues, you can also get them at Dollar Tree. And especially if you have a marble top for last Tuesday's lab, you don't want to get some of the chemicals on there. It could damage that or cause problems if it's your house or somebody else's, like your parents. So, but that's a good thing. Thank you for letting me know. I don't go to a Dollar Tree that often. I keep on forgetting there's one not far from my house. But anyways, that's a good thing. All right. Any questions about today's lab? And all you have to do is balance those chemical equations. You can rewrite it underneath if there's not enough room on the sheet where I have the actual equation. And I'd highly recommend you do like I do, write down how many atoms on each side so you can check off its balance. No, Yulia, you don't have to write G or S down. That just ignore. Okay, excellent. All right, let's get, oh, I've got to open it first. Hold on.
Professor, for which lab did you say you changed the date on?
The one we did Tuesday. Let's go find out. And please call me Dr. White.
Okay, Dr. White.
Thank you. This is a personal thing of mine. You can be a professor and not have a PhD, but if you have a PhD, you can be a professor, or part-time or adjunct faculty are not called professors. Well, let's see. If we look at, I have it Saturday the 1st. I'm going to change this right now. By the powers granted in me by me, let's exit this. You can see something top secret. And I'll give you till Wednesday. Because with the, with the holiday and everything, this will give you extra time. Remember, don't tell anybody I'm being nice. All right. So whoever asks when is it due, it's due by next Wednesday. So you got plenty of time to do it and have fun. It should be a real fun lab. You're welcome. Again, don't tell anybody I'm being nice. All right, why are you not? That's weird. I have too many windows open and I couldn't get my bar up. Now I can get my bar up. I can't. And I can do it this way. All right. Now it's working. All right. Everybody give me a thumbs up if you can see the mole on your screen. Thank you. All right, let's get back to work. All right, yesterday I talked about probably one of the most important concepts to me personally in chemistry, general chemistry and organic chemistry. Well, you'll learn about that later in the semester, but that's the mole. And you should know that the mole is the chemist's counting unit. And it's time for Dr. White to be subtle. You should know that the mole is the chemist's counting unit. And this is a unit like a dozen means 12 to bakers or people who sell eggs. The mole is a unit that contains 6.02 times 10 to the 23rd units. And those units could be anything. Yesterday, I told you about my favorite birthday gift, hopefully somebody gives me, and that's a mole of pennies. That'd be 6.02 times 10 to the 23rd pennies. That would be like having 100 million piles, and each pile has $1 billion. Or if you just want to give me a certified check, for 100 million times $1 billion. Whoa, that's a lot of money. But it's just a mole of pennies. But the mole is 6.02 times 10 to the 23rd. And you should know that's called Avogadro's number. If I ask on a test, what's Avogadro's number? It's 6.02 times 10 to the 23rd. Now, Avogadro's number is a calculated number. You actually go in the lab and determine it. And for this class, I use Avogadro's number to 3 significant figures. 6.02 is 3 significant figures. Let's see something real quick. That's not what I wanted to do. And here someone has Avogadro's number, 6.0221408. That's 2, 4, 6, 8 significant figures. Now, why would someone need that accurate? I have no idea. In my work, 6.02 works just fine. One time I happened to find a credible website where they had Avogadro's number 2. Are you ready for this? I think it was 18 significant figures. Why anybody would need that accurate, I don't know, but obviously somebody felt that to calculate it and measure it from the calculation. So this is Avogadro's number, 6.02 times 10 to the 23rd. Now, why are you getting all excited about a mole? What's so important about it? Now, when we talk about a mole, here's, I better do something right now. Everybody, take a deep breath. Let it out. Take a deep breath. Let it out. Are you nice and relaxed? I hope you are. Stay relaxed. We're going to be doing some math. Stay relaxed. We're going to be doing some algebra. Relax. I'm going to teach you how to do all that so you'll be able to do it successfully when you have to on a test. But there's some things you need to learn, and let's get going. When you have two things equal each other, if I have A equal B, when I have one thing equal another, like this, 1 mole equals Avogadro's number. By the way, 1 in 1 mole is a defined number, and that's an exact number, where 6.02 is 3 significant figures. But when I have two things equal each other, I can have 2 ratios, A divided by B, and not equal, a second ratio, B divided by A. And this is very important. In fact, it's very important. And so whenever I have two things, A equal B, you can have 2 ratios, A over B and B over A. So if I have 1 mole, by definition, equals 6.02 times 10 to the 23rd, Avogadro's number of things, I can have these 2 ratios. This would be, let's call this A, call this B. This would be the same as B over A, and this would be A over B. And they're not equal, they're separate, and that's why I have the word and. And this is something you will need to remember when we do some problems using a mole and Avogadro's number. Now, in chemistry, the important thing is atoms or molecules. And it turns out a mole of an element equals 6.02 times 10 to the 23rd atoms. A mole of and this is from element. Remember, elements are atoms. A mole of a compound is 6.02 times 10 to the 23rd molecules. And this would be from compounds. So the important thing you need to know is when you have two things, A equals B, we now can have two ratios. 6.02 atoms or 6.02 molecules per 1 mole, or 1 mole per 6.02 times 10 to the 23rd atoms or molecules. Now, if you go to important, the lecture folder, you'll see important information, test number 2 if you scroll down. In the past, students would have to memorize 1 mole of an element equals 6.02 times 10 to the 23rd atoms of that element. 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of that compound. Good news, you don't have to memorize it. By the way, I'm going to go a little longer until we do our break because I started late. Bad, Dr. White. Sorry about that. Today was a busy day. I gave 2 tests this morning. I had to go somewhere. I had to go to a doctor's appointment, my annual checkup, and then I made it here, unfortunately, a little late. Sorry about that. Thought I'd get here on time. So these are things you have to know about, but you don't have to memorize. Thank you, Dr. White. You're welcome. Now, let's talk about mole practice time number 1, including unit analysis. What's that? Well, let's find out. And let me make sure everybody can see this. You can. All right, let's look at the following problem. 5 points. Hint, how many molecules H2O, remember that's water, are in 7.12 moles of water? Well, what do I do? How do I solve this? Well, first of all, what are you being asked to find? And I put a question mark to identify that. You can use anything else you want, but that's what I use. We're trying to find molecules of water. What are we given? We're given 7.12 moles of water. So when you approach this problem and relax, this is called relax, a word problem, relax. The first thing you should do is find out what are you being asked to find? And it says how many molecules of water. What are you given? How many moles of water? And now I'm going to teach you about, are you ready for this? Your good buddy, your good friend, unit analysis. And my good buddy, my good friend, unit analysis has been my good buddy, my good friend since senior year in high school when I was taught it. And I've been using it for many, many decades. And I've taught this for a long time to students, and it helps. How do you use unit analysis? You start out with what you're given. And if we had a magic ratio, one number over another, what units do we want our answer to be in? Well, we figured it out right here. Molecules of water. And now it's time to use your good buddy, your good friend, unit analysis. I should warn you, the rest of the semester, I will be going for the Guinness Book of World Record, saying the most times in a semester, your good buddy, your good friend, unit analysis. Somebody keep count. But anyways, how do you use unit analysis? Whatever you're trying to get to, the units go on top of the ratio. Whatever you're trying to get rid of, I don't want moles in my final answer, you put on the bottom of that ratio. So let's do that. And I could have put here moles of water, which I have up here. Now the question is, where do we find a ratio of moles of a compound to molecules of a compound? And if you look at important information, test number 2, 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. So this part you don't have to write down, but I will. 1 mole compound equals 6.02 times 10 to the 23rd molecules. If I can spell. Did I ever tell you Dr. White was always the first one down in a spelling bee? And guess what? I still would be the first one down in a spelling bee. And remember what I just taught you. If you have two things, A equals B, therefore, that's what these 3 dots mean in math, therefore, you have A divided by B ratio that you have, and B divided by A. If I call this A, I call this B. Notice up here, I have molecules of water, and I'm going to use this number, 6.02 times 10 to the 23rd. And what's the moles? 1. Because from this equation, we can have 2 ratios. Six point oh two times 10 to the 23rd molecules per 1 mole, and which we don't need the second one, but I'll still 1 mole per 6.02 times 10 to the 23rd molecules, or molecules. And if you don't write the S there, that's okay. And now if I look at this, I can proceed. And what do? I look at the units. And that's why this is called unit analysis. If we look at this, if I multiply this times the units, and I'm going to come down here, I have moles of water. Forget about the numbers, times molecules of water divided by moles of water. Again, I'm not looking at the number, this the units. Now, something you should remember, anything divided by itself equals the number 1. So moles of water divided by moles of water, guess what? Cancel out. Become the number 1, and 1 times molecules of water, the units, we're not interested in numbers yet, becomes molecules of water. And if we look up above, that's the unit we want our answer to be in. So at this point, I can say moles of water divided by moles of water cancel out, and I'm left with the right units. And now I can say, where did I hide you? That's a good question. Ah, here it is. I'm looking for where's my calculator. And now I'm going to turn it on, clear it. I'm in scientific notation. I have 7.12 times 6.02 blue double E 23, 6.02 times 10 to the 23. My calculator gives me this number. And remember, when you're multiplying and dividing, you get the same number of significant figures in your answer as the number that you're multiplying, dividing, that has the fewest significant figures. 7.12 has 3 significant figures. 6.02 has 3 significant figures. The number 1 is an exact number. Exact numbers are not used to consider significant figures in an answer for multiplication, division, or later on, I'll teach you addition. So the lowest number, either one of these, is 3. So now we have to round this off to 3 significant figures. Keep the 4, keep the 2, keep the 8. Use the 6 to round off. Is that 4 or higher, or 4 or less, or 5 or higher? And the answer is 5 or higher. So I'm going to drop that, increase this by 1. And the correct answer for this problem, which I'm running out of room, I'll write it right here, would be 4.29 times 10 to the 24th molecules of water. Now, all the stuff underneath here that I just circled, you do not need. And same thing right here, I should have circled this too. You don't have to put down, but I'm showing you in this problem where I got these numbers. Now, when you do a problem like this, if you just write down a number as an answer and it's wrong, you get 0 points. If you show me your work like this and you made a math error, say you put down 5.11 times 10 to the 15th, but you had this 7.12 like this, Avogadro's number, and the 1, I'd say, oh, you made a math error. It's a 5-point question. I'll just take off 1 point. So on my test, which these are not multiple choice, you have to show you don't have to show your work, but I highly recommend you show your work. And the key to this is your good buddy, your good friend, unit analysis. And if I look, I think this is about time. Let's take a 5-minute break. I'll come back in 5 minutes and we'll do some more of these. Practice makes perfect, helps you get a good grade, and we're going to practice some more. So I'll see you in 5 minutes and we'll continue on. let's get going. All right, before the break, I was showing you one of the most important concepts, unit analysis. And in test number 2, important information, we have 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. We also have 1 mole of a compound equals Avogadro's number, that's 6.02 times 10 to the 23rd molecules of a compound. And as I mentioned, if you have 2 things equal, you can have 2 ratios, A over B, and not equal, the separate ratio, B over A. In this case, will be 1 mole equal Avogadro's number of atoms or molecules. So let's do another problem. Oh, let's go real expensive. All right, 5 points. How many moles AU, remember that's gold, are 7.1134 times 10 to the 31st atoms of gold? But before we do this, I forgot to say something. Don't forget, test number 1 is due tomorrow by 4 p.m. Also, next Monday in our Zoom meeting, I will go through all the answers for test number 1, but I'll cut it out. How do you like these special effects? I'll cut it out of the video. I'll post it as a separate video where I go over the answers for test number 1 as a private video, and I'll send out an email after I do that on Monday. In other words, talk about it in our Zoom meeting. I'll create, just like I do now with these meetings, a video, but that one with the answers for test 1 will be private. I will send out an email with the URL so you can look at it. I just don't want it publicly out on YouTube for the rest of eternity. So that's why I do it. Also, by Sunday, 1 p.m. or sooner, I will have posted in Blackboard your test number 1 score. And at that point, after I post it in there, I'll send out an email to all of you that it's available. Also, hopefully by Sunday afternoon, if not by 1, or maybe a little after, each one of you will get an individual email with the points you received for each answer you put on test number 1. And that way you can tell, what did I get wrong? And if you got something wrong, you can either come Monday to our Zoom meeting and watch me go through all the right answers and how to get them, or watch the video. All right, back to our problem. All right, so how do we proceed? Oh no, what do I do? Well, the first thing you do is, what are we being asked to find? And the answer is moles of gold. So I like to put a question mark. I don't know how I came up with that, but I do, and I have been for many, 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 many years. And that's what we're trying to find. And it's important to put the units there, moles of gold. Next, what are we given? This. We have 7.1134 times 10 to the 31st atoms of gold. Well, that's all. Once we've read this and done this, we never have to look at the problem again, because this is all I need to solve it. And so what do we have to start with? Well, only this. And you don't have to put the word goal of, but be sure to put the unit atoms and of what atom or element or molecule you're trying to find. Now, what units do we want our answer to be in? Well, we figured that out. Moles of gold. And now, if we had a magic ratio that can convert atoms of gold to moles of gold, what's there? And guess what? It's time to use your good buddy, your good friend, unit analysis. And how does that work? Whatever you're trying to get to the units, those units go on top of the ratio. Whatever you're trying to get rid of, those units go underneath of the ratio. And now write that in. And now where do we get a relationship between moles of an element and atoms of an element? Remember, where is moles equal to atoms of an element? And in case you forgot, in the past students would have to memorize this. Good news. You can go to important information, test number 2. This will be on the last, actually there's more than one, the last page of test number 2 when I send it out, no, I don't know, a couple of weeks. And you'll be able to see this, but you got to know how to use it. So we know 1 mole of a compound equals Avogadro's number of atoms of that element, not compound element. Now, I'm going to write it down here. You do not, but just to remind you. So we have from test number 2 important information. 1 mole of a compound equals Avogadro's number, 6.02, times 10 to the 23rd atoms of that compound. Remember, A equals B. There are 2 ratios, A over B, and B over A. This is A, this is B. And if I look here, where do I get a relationship? Moles and atoms? From here. 1 mole of an element is 6.02 times 10 to the 23rd atoms of that element. Now, before I pick up my calculator, before I do this, I'm going to check my units. And notice here we have atoms of gold divided by atoms of gold. And anything divided by itself equals the number 1, meaning it's canceled out. And here, that's canceled out. What units am I left with? Moles of gold. What units am I trying to get to? Moles of gold. I've set it up correctly. Yay! So now I can pick up my calculator, clear it, put 7.1134 blue double E for times 10 to the 31st divided by 6.02 blue double E, that's times 10 to the 23rd. And I hit enter, and my calculator gives me, are you ready for this? This number. $1.181627907 times 10 to the 8th. Now, remember, on test number 2, underneath your name, it will say, please use proper significant figures for all calculated answers. And when you do a multiplication division, you get the same number of significant figures in your answer as the number that has the fewest significant figures you're multiplying dividing by. So let's take a look. This number, all non-zero numbers are significant. 1, 2, 3, 4, 5 significant figures. The 1 is part of the definition, so that's the exact number and plays no role in determining significant figures of your answer. Avogadro's number, 6 zeros after decimal and also combined, so that's significant. And the 2 is, that's 3 significant figures. So, which is the lower number, 3 or 5? And hopefully I'll pick 3. So now we have to round this off to 3 significant figures. Keep the 1, keep the 1, keep the 8. Use the 1 to round off. Is that 4 or less or 5 or higher? And hopefully, I like my buzzer sound. But anyways, hopefully it's not driving any of you crazy. But it's 4 or less. So I'm going to drop this, 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 this. A lot of this is to drop. And the correct answer for this problem would be 1.18 times 10 to the 8th moles of gold. Now, if you don't put the units, I don't take off points. But if you get the significant figures wrong, I'll take off 1 point. If you make say you wrote down 3.45 times 10 to the 6th, but you showed all this work up here, I'd say, oh, you made a math error and I'll only take off 1 point. But if you just write down an answer and don't show your work and it's wrong, you get 0 points. Now, there's one other thing which I mentioned earlier where I did, but let's look at this. What if we set this up backwards? And we had atoms of gold times atoms, actually it's upside down, not backwards, per moles AU. Say you set it up this way and you had a number here, number here, number here. How do you know you made a mistake? Well, let's look at what is the answer, the units of your answer. If you do it this way, which I'll remind you is wrong, but how do you know it's wrong? What units would my answer be? Up here, atoms divided by atoms cancel out, and I got the right units, moles of AU. But the wrong way, nothing cancels out, so your answer, if you do it wrong, nothing cancels out, and this is not what we want. You want your answer to have the units atoms of AU times atoms of AU per moles of AU? No, you want moles of AU. So this again, if you did it backwards here, upside down, whoop, you can say, I made a mistake. I better go back and do something different. All right, let's do another one. Now, this time, I'm going to let you try stepwise. Let me peek up here. What did I do? Now, HCl is called hydrochloric acid. Near the end of the semester, we'll learn more about this. Hydrochloric acid is the molecule, the acid in your stomach that helps break down food. But now you're being asked 5 points each, or 5 points. How many moles of HCl are in 8.1 times 10 to the 45th molecules of HCl? So we're going to do this stepwise. The first thing I'm going to ask you to do, and then I'll do it, is over here, write down what are you being asked to find, what are you given? Your turn. Don't solve the problem. We're doing this stepwise. All I'm asking you to write down and vote yes. When you finish, you figured out what are you being asked to find, what are you given? Oh, somebody beat me to it already. Okay, they got. Again, what are you being asked to find? What are you given? All right, my turn. Isn't it nice I share the fun? So what are we being asked? How many moles of HCl? Now, I like to use a question mark. You can use whatever you want, a smiley face or whatever. I don't know about that, but, well, yes, you could. I won't, but you could. What are we given? Well, right here, we have 8.1 times 10 to the 45th molecules of hydrochloric acid, HCl. So now that we have this, there was only one thing we can start with, and that's this number. Now, over here, I'm going to let you have some more fun. What units do you want your answer to be in? Your turn. Looks like the number 4. Let me change. Let me draw a nicer arrow. What units do you want your answer to be in? And let me get the pull out. And vote yes when you figured it out. By the way, hint, hint, question mark, big hint. There you go. All right, my turn. We want, because we figured it out right here, we want our answer to be unit-wise moles of HCl. Now, if we had a conversion ratio, something divided by something, and again, I'm doing this stepwise, what units do you want on top of the ratio? Not numbers, just units. And what units do you want underneath the ratio? Your turn to have some fun, a lot more fun. It's time to use your good buddy, your good friend, unit analysis. I'm asking you, what units do you want on top and bottom of that ratio? It's my turn. It's time to use your good buddy, your good friend, unit analysis. Whatever units I'm trying to get to goes on top of the ratio. whatever units I'm trying to get rid of go underneath. And I just thought of something. Let me write in the units. Then there's something I should ask everybody. I want moles of HCl on top, and I want molecules HCl on the bottom. And what I forgot to ask is if any of you are colorblind, and now I'm going to be very serious, let me know if I need to use another color. When I do these with unit analysis, notice I use the red arrows. That's the habit of mine. When I worked at 2 different companies, I had in each company a chemist reporting to me in my research group who was red-green colorblind. And if there was some test where they had to look at the color and that color was red or green, another chemist would help that person out because they couldn't see red-green colors because they were red-green colorblind. So I use red. If anybody is colorblind, red-green, email me in private and let me know, and I'll pick another color. You let me know. If not, I'll continue to use red. By the way, personal note, can you guess what my favorite color is? This is not my birthstone. This isn't, can you guess what my favorite color is? It's above my monitor. Can you guess what my favorite color is? Oh, one more. Yep, it's, oh, wait, one last one. Yep, Dr. White loves the color red, ruby or red, it's red. But anyways, let's get back to our problem. Now, we set this up by using your good buddy, your good friend, unit analysis. So where do we get the numbers that go in this ratio? Where do you find a relationship between moles of a compound, that's what HCl is, and molecules of a compound? Well, in case you forgot, you can go to test number 2, important information, and right here, 1 mole of a compound equals Avogadro's number 6.02 times 10 to the 23rd molecules of that compound. Now, you don't have to do this, but since you're all new at this, I'll rewrite it here. If we're in a classroom, on the board, there would be, or on the screen, projection screen, you'd see test number 2, important information. And I'd be doing this on the whiteboard on either side of that screen, but we don't do that in Zoom. So I'm going to write this. You don't have to do when you're solving a problem. And now what are we going to do when we have A equals B? There are 2 ratios, A over B and B over A. And if we look up here, if I have 1 mole of a compound, and that compound is HCl, how many molecules of that compound do I have? Avogadro's number. Now, before I pick up my calculator over here, I'm going to look at, do the units cancel out to give me the same units I want my answer? Notice here I have molecules of HCl divided by molecules of HCl. Remember, anything divided by itself equals the number 1, cancels out. So this cancels out. What units am I left with? Moles of HCl. And that's what I want my answer. So now I can happily, well, I do it happily. You can do it any way you want. Hopefully it is happily. Clear my calculator. Have 8.1 blue double E, which is times 10 to the 45th, divided by Avogadro's number 6.02 blue double E times 10 to the 23rd. Hit enter, and my calculator gives me this number. And remember that when you do multiplication division, the number you get should have the same number of significant figures as the answer that has the fewest significant figures. So if we look over here, this has 8.1, 2 significant figures. All non-zero numbers are significant. Avogadro's number, 6.02, is 3 significant figures for my class. You can find it more, but for mine, that's what you should be using. And 1 is part of the definition, and that's an exact number, which is not figured in determining the significant figures of your answer in a multiplication or division. Now, hard part, which is the smaller number? Lower number, 2 or 3. And time's up. Hopefully you pick 2. So that means we have to round this off to 2 significant figures. How do we do that? Keep the 1. Keep the 3. That's my 2 significant figures. Use the 4 to round off. Is that 4 or less? Well, yeah, it's 4. So I drop this and everything after it. And my answer will be 1.3 times 10 to the 22nd. And you don't have to, hold on, let me write this better. On a whiteboard, I can do the same thing where I have to erase it and rewrite it. And moles of HCl. And if you don't put the units down, just put 1.3 times 10 to 22, I would still mark it correct. And that's how you do it. Oh, let's do one more. Have some fun. Now, the question is 5 points. How many molecules HF is, well, hold on, let me change this. I don't want to talk about HF yet. Let's change it to another molecule, which I can talk about. HF we'll talk about later. NaF is sodium fluoride. And it's a molecule put in your toothpaste to help reduce the cavities you get. All right, so the question is, how many molecules NaF, sodium fluoride, are in 2.117 times 10 to the third moles of sodium fluoride? We're going to do this stepwise again. First step, what are you being asked to find? What are you given? Your turn. Again, what are you being asked to find? What are you given? All right, my turn. What are you being asked to find? How many molecules sodium fluoride? So I like to use a question mark, as you'll learn this whole semester. We're trying to find this, and we're looking at just the units. What are we given? This number. We have 2.117 times 10 to the third moles, and you usually don't put the S in there, even though you say it, NaF. Now, one thing I should point out, if you look at certain books, they'll write mole, MOL. That's the newer way. I like the old way. I'm old-fashioned. All right. Now, there's only one number we have to start with. This. Because here we're trying to find that. Now, what units do you want your answer to be in? Your turn. What units do you want your answer to be in? And I will be patient. I'll give everybody time to finish. Remember, all I'm asking is what units do you want your answer to be in? Hint. All right. And that's why you take the trouble to do this right here. This immediately tells me, the question mark tells me that's the units I'm trying to get. Now, if we had a magic ratio, it's not magic, it's chemistry, what units would go on top? Not number, just what units would go underneath. And we're going to go a little longer today because I started late because I got out of my doctor's appointment way later than I thought I would. Sorry about that. All right. How do we figure out what units go on top and bottom of this ratio? It's time to use your good buddy, your good friend, unit analysis. I love this whistle. By the way, before I do it, these siren whistles are made by a company that's unfortunately no longer in business from West Germany. I got these years ago. I have 4 of them, and they never leave my house because I don't want to lose them because you can't get them anymore, not that quality. By the way, important personal tip. Never let the little kid inside of you disappear. Always keep that little kid in there. And Dr. White, that little kid is always there, having fun and helping me have fun. That's just a personal observation. All right, let's get back to work. We're trying to use unit analysis, your good buddy, your good friend, to determine what goes on top of the ratio units wise. Whatever you're trying to get to goes on top of the ratio. Whatever you don't want to have, get rid of in your units of your final answer goes underneath. And now I'll write those in. And now I have to find, where do I find a relationship between moles of a compound and molecules of a compound. And if you look at important information, test number 2, or come back and look at this video when you're doing the practice problems for this chapter 5, you will see 1 mole of a compound equals Avogadro's molecules of that compound. And I have it written up here. Remember, when you have 1 mole of something and 1 mole of a compound equals Avogadro's number of that compound. And this part you don't have to write, but I'm showing you. You have A equal B. You can have 2 ratios, A over B and B over A. And from this, I know 1 mole of a compound equals Avogadro's number. And before I pick up my calculator right here, I'm going to look at my units. What cancels out? Here you have moles of sodium fluoride divided by moles of sodium fluoride. Remember, anything divided by itself equals the number 1, meaning it's canceled out. So this cancels out. What units do I have left? Molecules of sodium fluoride. Is that what I want? Yes. So I'm on the right track. By the way, if you just wrote this, everything you see on the screen, and didn't put an answer down, I'd still give you 4 points. Maybe your calculator died or something, because you showed me you know how to do it, you just didn't finish it. But my calculator works, so I'm going to finish it. And I'll clear it. 2.117 Lu double E times 10 to the third times 6.02 Lu double E, which is 10 to the 23rd, divided by 1 is going to be that, so I don't have to divide by 1. And my calculator gives me this number. Now, if you put that down, I'm going to take off a point because you didn't do proper significant figures. I'm going to let you try it. Your turn. Why don't you figure out what would be the correct answer? 1.274434 times 10 to the 27th is not the correct answer because you haven't used proper significant figures. On test 2, like test 1, it will say underneath your name, please use proper significant figures for all calculated answers, which this is, and for a multiplication division, you get the same number of significant figures in your answer as the number you multiply and divide by that has the fewest significant figures. So your turn to figure out what would be the right answer. And then I'll do it. And when you're done, don't forget to vote, and we'll give everybody time to finish. Oh, everybody's finished. My turn. You'll hear me say that a lot this semester. My turn, because I share the fun. How do we do this? You get the same number of significant figures in your answer as the number that has the fewest significant figures. So if we look here, we have how many significant figures? 1, 2, 3, 4. All non-zero numbers are significant. If we look here, we have 6. Ooh, a 0 after a decimal point is also confined. That's significant. A 2. This is 3 significant figures. The 1 is an exact number, part of the definition, 1 mole, and that doesn't play a role in determining significant figures. So our answer should have the same number of significant figures as the number you're multiplying, dividing, that has the fewest significant figures. Well, you've got two choices, 4 or 3. Which is the lower number? Hopefully you pick 3. So now we have to round this off to 3 significant figures. Keep the 1, keep the 2, keep the 7. Use the 4 to round off. I use those double squiggly lines. I think that's what I call them, squiggly lines, and determine to round off is the number we're using to round off 4 or less, or 5 or higher. Hopefully you pick 4 or less. So I'm going to drop this, 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 and the correct answer. I don't know what's happening in my, for some reason, oops. Everything just burped on me. Let's get that back. That was strange. And the correct answer would be 1.27 times 10 to the 27th moles of sodium fluoride. And let me just remind you, how did we get there? Here's our problem. We read the problem. The first thing, and just relax, take a deep breath. This is called the word problem. And you do word problems, find out first, what are you being asked to find? The units. Second, what are you given? And we're trying to find molecules of sodium fluoride. I like putting a question mark. You can use whatever symbol you want to help you remember what are you being asked to find. Next, what are you given? If you look at this is the only number we're given, 2.117 times 10 to the third moles of sodium fluoride. This is where we start with, where we have this number. We're trying to go to, and let me move my pictures over here, this units in our answer, and the red arrows, if we had a ratio that could convert moles of sodium fluoride to molecules of sodium fluoride, we use our good buddy, our good friend, unit analysis. What we're trying to get to goes on top of the ratio units. What we're trying to get rid of goes underneath. Where do we get a relationship between moles of a molecule? NAF is a molecule, and molecules of molecule or a compound. And if you forget, you can go to important information. 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. And that's where we get those numbers we put in here. Then I use my good buddy, my good friend, unit analysis again. Notice I have moles of sodium fluoride divided by moles of sodium fluoride. Anything divided by itself is the number 1. That cancels out. I'm left with, yay, moles of sodium fluoride. And now I do the math. And remember, you get the same number of significant figures in a multiplication and division as the number with the fewest significant figures that you multiply and divide by. But exact numbers are not used to determine significant figures. And this one, the first number has 4 significant, 6.02 times 10 to the 23rd, 3 significant. So I round this off. This is the number my calculator gave me. And that's got 2, 4, 6, 7 significant figures. Wow. And to get that to 3 significant figures, keep the 1, that's my first significant figure, the 2, my second, the 7, my 3. I use the next number, which in this case is 4, to round off. And when it's 4 or less, you drop that number and everything afterward. If we're 5 or higher, I drop that number and everything higher and increase the 7 by 1, but I don't. If I look at the clock, wow, time flies when you're having fun with Dr. White and your good buddy and your good friend, unit analysis. Now, on a serious note, don't forget, make sure you have test number 1, your answers uploaded as a single PDF file by tomorrow, 4 p.m. Don't forget, next Monday, I will go through test number 1 answers, and I'll cut it out of video. I like my special effects, but I can do it. I'm ambidextrous. I can do it at the same. Anyways, I will do it. I will go through the answers on Monday, and I'll post a separate private video with those answer coverage, and I'll send you the URL to find it so you can look at it if you're not here on Monday. And with that, have a nice rest of the week, a nice weekend. I've got a lot to do. My other class I teach at another school, I gave a test today. So I'll be grading a lot of tests because I don't use Scantron, which are whoop, run it through a machine. You're done in 3 or 5 minutes. This is going to take me a couple hours each class, but you're worth it. I think they're better tests, the ones I give, than all multiple choice. That's my personal opinion. With that, I'll say, gang gesund. Goodbye. Stole that from Granny.